Welcome to episode 140 of Paper Brief. I'm Charlie, your host, and together with Cleo, our ML and tech expert, we're diving into an exciting paper today, LEGO, Learning Egocentric Action Frame Generation via Visual Instruction Tuning. So Cleo, can you give us a bird's eye view of what this research is all about?
Sure. This paper explores an interesting niche in machine learning that combines vision and language models with diffusion models to generate actions from a first-person view. It's about understanding and generating the next frame of what a person might see given a specific action they're performing.
Sounds pretty cutting edge. How exactly do they manage to do this?
They use a latent diffusion model to synthesize an action frame based on an input frame and a detailed action description. There's a lot of innovation in how they condition the U-Net in the diffusion model to understand the action described.
So where does the instruction tuning part come in?
Good question. They fine-tune a vision and language model, VLLM, with visual instructions, which helps in generating a richer action description. This enriched text is then used to guide the image generation process by informing the diffusion model about the action being performed.
Okay, but what about the raw data they're working with? Can you touch on that?
Certainly. The team curated a dataset consisting of egocentric actions from the EGO4D and Epic Kitchens datasets, ensuring a variety of actions and camera motions.
That must have been quite the task. And how do they measure whether their generated frames are accurate?
They use several image-to-image similarity metrics, like the Frechet inception distance and learned perceptual image patch similarity, and also a user study for a more subjective assessment.
So it seems like they've made some significant advancements, but I'm curious about practical applications. Can you give some examples?
Absolutely. Imagine a system that can predict what a cook will do next in a kitchen just by looking at their actions, or a tool that assists people by visualizing the steps to fix a bike. The applications for assistive technologies and robotics are vast.
That's pretty awesome to think about. Before we wrap up, is there anything particularly striking about this research to you?
What stands out to me is the interdisciplinary nature of this work. It really showcases the power of combining various branches of AI to create something that feels almost sci-fi.
It definitely sounds like the sort of thing you'd see in a movie. Thanks for illuminating this paper for us, Cleo. That's all for episode 140 of Paper Brief. Catch us next time for more insights into the latest in ML research.